This talk is about performance monitoring. And I know everybody's profiling the codes. I know everybody knows how to do this. I want to show you a different way of doing it. And I am going to show the performance of an ADIOS application that uses Kokkos so that the title does make sense. But it's mostly on real-time monitoring. And if you look at the figures, you have the application. Everybody knows what that is. You have Kokkos. I'm assuming everybody knows what Kokkos is. And then underneath, you have some profiling tool. In this case, it's Tau. Usually, Tau produces files. And then after your application finishes, you load those files, and you kind of look at the performance of your application. This talk will show you what can happen when you slap ADIOS to your profiler and play with, sure, you can still store your counters, your performance counters, but you can also stream it, which will allow you to watch in real time the performance of your application. All right, so what is Tau? And by the way, I chose Tau. Ooh, how many of you have used Tau? Ah, excellent. So I don't even need this slide. All right, I'll go back. I'm choosing Tau, so everybody knows Tau. You can use Tau to monitor the performance. It has a bunch of tools so that you can visualize it. I'm not a developer for this, so I don't care too much, but they graciously agreed to put ADIOS as a plugin in Tau. So now if you turn off a flag, you can create ADIOS files that contain the performance of your application. And it can be any other performance tool that wants to add ADIOS, but for now, let's look at Taus. All right, what about ADIOS? How many of you have used ADIOS? Oh, I'm depressed. All right, how many of you have used HDF5? Excellent. Even more depressing. So ADIOS is the equivalent of HDF5, but we do more than just files. We can also do streaming. So it has a publish-subscribe type of interface where applications basically publish whatever they want to send to storage. And then they offload the decision of how to do that to the I/O library in the same way that HDF5 does it. It's just that we have a concept of step that doesn't exist in HDF5 that allows us to kind of progress in the step. You can see it as a transaction. We can progress an application through steps, which allows us to stream each step. So once you put a step out there, a transaction, we can stream it to other applications that are using it. And we do that locally, in situ, or over wide area networks. And now Tau has ADIOS plugin, which allows you to create ADIOS files. We don't have time to understand what ADIOS files look like. I was hoping you would know this already, but it's a way of organizing your data. It's a self-described format that allows you to interrogate different variables that Tau is putting out. So all performance counters now that Tau usually put in a file are now organized in this type of format, and you can interrogate with an ADIOS API all these variables. And then once the data is in ADIOS format, you can basically query it so that you can bring only the loops of your application where the performance was below a certain threshold or above a certain threshold. You can add it to campaigns so that you organize it. For example, you attach performance to a run so that in the future you can look at all the runs that perform poorly and you try to understand what you did wrong there. You can stream it in real time, and you can do this over the wide area networks as a remote access. So the live demo that I wanted to do that I'm not doing was running an application that is using ADIOS for its I/O and Kokkos for the computational part. Then I'm running Tau with ADIOS. So I'm running that application on Frontier, and then I'm running Tau with ADIOS on my laptop. Well, Tau runs on Frontier, but I'm running ADIOS on my laptop as well. And I have a Python script, that's the one on the right, that just parses all the metrics that are generated by Tau. I choose the 4 most expensive kernels, and then I plot something like this on the bottom. because I wanted to do a live demo, I'm not running with that many nodes. So this is what you would have seen. I have one node of Frontier, 8 GPUs, 8 MPI ranks. My application is doing some evolution of two substances, the Gray-Scott reaction. Then MPI stencil exchange. And then you perform the I/O. And because I use the same plotting functions, the color are different because when ADIOS is using the Kokkos backend, the kernel that computes the statistics for your data becomes very little and it's no longer. So it was the main blue here was our our I/O library that was computing min-maxes for all the blocks. Because it's a lot of data, it was more than the computation part of the application. With Kokkos inside ADIOS, we can offload the computation of the statistics, and it becomes the red color there. The purple is the MPI exchange, and then the blue on the left side is the equivalent of the orange on the right side. And I've done this on my laptop while Gray-Scott was running on Frontier. Yeah, I know, I couldn't play with the colors. I didn't want to play with the colors. But the point is, you can do this in real time. You don't have to wait for your application to finish. And this is it. I'm leaving links here. I'm hoping more people are going to know what ADIOS is after this. Thank you.
Yeah. Thank you so much. Thank you so much. Yeah, ADIOS is great. Obviously, any questions? No? No? Oh. Here, look, where's this weird guy who has a question? You know him? No, he's asking if this is a new way of hiding the latency, before you can start profiling, because you can already start doing it while your program is running or compiling or whatever.
Exactly.
Very good, Damien. You got totally right. Okay.